Hello everyone and welcome back to Nunley Math. I'm your host Aaron Nunley. I want to thank you for taking the time to join us here again today as we begin our third lesson in our graphs of functions series. We've already talked about the linear function. We've already talked about the quadratic function. We're going to talk about a third function here today. But because this is our third video, I am going to avoid a lot of the preliminary stuff. I'm just going to dive right in, hoping that you've already watched those videos and you know kind of what's going on. As always, I do have a function shown here for you. This is f of x equals the absolute value of x. F of x equals the absolute value of x. And as always, we are going to graph this the slowest possible way we can in order to learn some information that will help us graph it much more quickly in the future. So we're going to graph this the hard way, and that is by plotting points. We're going to talk about some characteristics that are revealed, and then we're going to talk about ways those characteristics can help us do this much more quickly in the future. Now remember, we don't know which values of x we're going to be able to stick in that will work. We are not given a list of values of x, so we're just going to pick some values, plug them in, see what happens. I tend to pick values that are going to fall along the part of the number line that I have shown for you because it wouldn't make sense for me to pick values that are out here, and it wouldn't make sense for me to give you a function that has values that are out here. So we're just going to pick numbers along the x-axis here, and we'll just see what happens, okay? Again, I would recommend that you pause the video, you try and plot these points on your own without watching me, and then that you turn the video on and maybe skim through and see whether or not your values match mine, and then just hop right in at the end of getting these graphed and we'll talk about what it all means. So here we go. I'm going to start with 0. I usually start with 0, especially early on, because it tends to be easy to work with. I plug it in. The rule says no matter what value of x you stick into rule f, we're always going to take its absolute value, and so we get a 0 out, giving us the coordinate 0, 0, which is here. I'm going to put in a 1 and get out a 1, which is here. I'm going to put in a 2. Absolute value of 2 is 2. I'm going to put in a 2, 2, and graph it here. I'll do the same with 3, and I'll do the same with 4. After graphing those 4, I can see pretty well that if I continue, I'm just going to get the same things going on over and over again. Notice if I put in a 0, I got a 0. Put in a 1, get a 1. Put in a 2. If I put in a 5, I can pretty well predict I'm going to get out a 5. If I put in a 10, I can pretty well predict I'm going to get a 10. Because of that, there's really not a whole lot of value in me continuing to insert points that are over here. I already know the information I need to know. What I want to do is see what's happening the other way and see if there's any difference. So I'm going to stick in a -1. The absolute value of -1 is 1, so I graph that. The absolute value of -2 is 2, and I put in a -3, and I put in a -4. Hopefully at this point you begin to see that this graph is making a particular shape, and hopefully you've realized that that shape is a V. Notice, if I continue to put values in here, my graph is going to continue to go up. If I continue to pick values over here, like -10, the absolute value of -10 is +10, the graph is going to continue to go up. And I'm not really surprised to see that happen, because this type of graph always, always, always makes a V. Now, this type of graph might give you a wide V like we have here. It could give you a tall, skinny V like we have here. The entire V could be moved over and down, or it could be moved over and up. In fact, you could get V's that are upside down. But no matter what happens, when you graph something that looks like this, it will always, always, always make a V for you. By the way, we call these absolute value functions for, well, obvious reasons. And an absolute value function will always give you a V. When we look at absolute value functions, we want to think about where these are going right and left. We want to think about where they're going up and down. So if I were to start off at this point right here, and I begin sticking in values and looking what happens to my graph as it goes to the right. notice that the arrow is going to the right forever. If I go to the left, you'll notice the arrow is also going to the left forever. Since I can go right and left forever, the domain controls right and left, I know that no matter what number I stick in, it's going to give me a value, as long as it's a real number. In other words, no matter what value I stick in for x, something will come out. Something will come out. That's what the domain says. You can stick in anything you want and something will come out. Let's talk about the range. The range is where this graph goes up and down. If I look to the right, this graph goes up forever. If I look to the left, this graph goes up forever. In fact, if I were to start at the left, I go up forever and I start moving down, 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 down to here. And at this point, my graph starts going back up, 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 up. The graph goes up forever, but it never goes below this point. No matter what value you stick in to your domain, if you stick it into this rule, it will come out as 0 or larger. So we say that the range is any value will work as long as that value is 0 or larger. That's our range. Now, if you know a whole lot about absolute value, you're probably not really surprised by that because absolute values always give you positive outcomes. No matter what you stick in, it's going to come out positive. So in this particular example, no matter what I stick in, I'm not going to be able to get a negative number. You stick in a 3, you get a positive 3. You stick in a negative 3, you get a positive 3. No matter what you stick in, it's going to come out positive. Now, let me go ahead and erase some of this ink. And let's talk a little more about this. We want to focus on some key features of this particular graph. Do you see anything that's interesting? Hopefully, if you already watched the video on quadratic functions, you recognize that this particular function also has a line of symmetry through the middle. You'll remember that a line of symmetry says that whatever you do on one side, the line of symmetry acts like a mirror and recreates it on the other side. So since this was 4 spaces away, this was 4 spaces away. Since this was 3 spaces away, this is 3 spaces away. And in fact, no matter which point you get, it gets recreated on the other side. It's called a line of symmetry, and it's the line x equals 0. Remember, vertical lines are always x equals something because when you look at your coordinates, it's 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. The y value keeps changing, but the x is always 0. Why do we care about the line of symmetry? Well, it took me, 9 points in order to draw this graph. That's what made it take so long. But if I knew there was a line of symmetry in the middle, I could just graph one side and then flip it over and get the other side for free. The effect of the line of symmetry is it cuts our work in half because once we know where that line of symmetry is, we can use the mirror to reflect these points over to the other side. Saves you a lot of trouble. One other key feature I want to make sure I mention is that this has a vertex. It has a vertex. The vertex will always be on the line of symmetry, and it's where your graph changes its behavior. Notice that here to the left, it's coming down, 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 until it reaches the vertex, and at the vertex, it goes back up, 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 up. This is the third of our 3 types of functions. You now have linear, you have quadratic, you now have absolute value, and we're beginning to get an idea of the shapes that go with them. That's 3 out of the 7 that we're going to be responsible for knowing. So make a mental note of this. Make sure you keep your mind open to patterns that you're seeing, because as we go into future functions, they're going to get a little bit more challenging, and it's going to be important for you to have these easier ones to use as a frame of reference. As always, thank you for watching. Make sure you hit the like and subscribe button, turn on your notifications for me, all right? As always as well, I wish you all the very best of luck. Take care of yourselves. Bye-bye.